Okay, welcome to Thursdays. And this is actually going to be my last video of the week. I won't be posting tomorrow, so no classes tomorrow. It'll just be a work period. So please keep working on your assignments. Also remember that it's a long weekend this weekend, so there's no school on Monday. Left you off on Tuesday. We had finished all the examples except one in the quadratic applications lesson. So I'm going to finish that one off today. It is similar to one we saw in the linear functions unit, the last unit. It's a table of values. So they don't give us the equation. They don't give us a picture. They give us a partial table, but it's an odd looking table of values because it has columns. Now remember, we can only use 2 columns of data to enter into our calculator when we're trying to find an equation of the function. So that therefore we're only going to be using 2 of these columns, and we'll have to read the question to figure out which columns they want us to use and how we actually complete the table. So this is a table of values where you actually have to do some pair. So this is the price, right, in dollars. They can sell 500 pairs of jeans. It is estimated that for every $2 decrease in price, the company sells 50 more pairs. Well, that makes sense, right? When they reduce the price, more people usually buy. And when you increase the price, usually fewer people buy. So where did they get this revenue? Well, that means if they sold 500 pairs of jeans at $80 a pair, this number times this number equals my $40,000, right? And once again, this is a dollar amount and this is a dollar amount. Okay. So it says complete the table of values. All right, well, let's read the question one more time. For every $2 decrease in price, so I'm just going to start with that number. A $2 decrease in price means $2 less. If I sell the jeans for $78, the company sells 50 more pairs. Okay, so that's 550. If I reduce a further $2, that would take me down to 76. I'm going to sell another 50 pair. If I reduce another $2, I sell another pair. Okay, so they obviously thought that 4 entries is enough. Okay, so I just have to figure out what these numbers are. So 550 times $78 gives me $42,900 in revenue. And then I get $45,600 in revenue. And I get $48,100 in revenue. Okay, so these are all dollars. So here's my table of values. Now, this is very important. I have 3 columns of numbers. It's often difficult to figure out what numbers you're supposed to use, but the question will always tell you what it wants you. Because technically I could use any 2 out of the 3 columns, but it asks me to determine the quadratic regression equation that models revenue as a function of price. So revenue and price. Revenue and price. Therefore, they want this column and this column, right? These are my 2 columns, and I'm not going to be using this column to enter into my calculator. So this will be my list 1. This will be my list 2. Okay, so once again, the question will always tell you what data they want you to use. So you know what to do. Make sure your calculator is cleared out. Enter my data in for list 1. That's under Stat Edit. Right? Just going to move this up a little bit. Give myself a little more room. Okay. Hopefully it's still nice and clear. So Stat Edit, I'm going to enter in 80 and 78 and 76 and 74. And then I'm going to enter in 40,000. Be careful of your zeros. 42,900. 45,600. and 48,100. All right, now if I want to take a look at this data, I'm going to have to turn my stat plot on. And let's see, I definitely going to have to change my windows, right? What window settings should we use? The nice thing about a table of values is it clearly gives you some guidelines on the window settings you're going to use, right? So my X-min, I mean, I could have my X-min from, I don't know, I'm going to say like 60 and my X-max. Actually, you know what? I'm going to put my min and my max at 0, or both my mins at 0s. I like starting at 0s. And then I'm going to do my max at, let's try 100, and my Y max at $50,000. Actually, that's not enough. Let's try, I'm going to try $80,000. I really don't know how much revenue I can make, so 50 is a bit small. So these are huge numbers. So 0 and 100, 0 and 80,000. I'm using zeros again because this is a quadrant 1 graph. Let's just see what I see for a graph now. Ooh, just see a little collection of dots right over here, right? It almost looks linear, right? We weren't given a lot of data. I'm wondering if it's asked for the quadratic though. So I guess this is a parabola. I guess it kind of loops like that. Let's see what happens. Stat calc. I'm choosing quadratic, number 5. So vars, y vars, function, y equals calculate. Okay, here's my equation. Negative 25x squared plus 250x plus 0. So y equals, I'm just going to put it down here, y equals negative 25x squared plus 2500x plus 0. I'm not going to put the 0 in. So let's see if this ends up being a quadratic. Now, if you look at your y equals screen, the equation will be pasted in. That's what you did with that vars, y vars. And when we look at the graph, there we go. So we actually just came up with 4 values that were at the outer or the right side of the parabola, right? It's kind of what we predict. Without knowing that this was quadratic, though, to me, that could have been linear, right? Okay, so here's my nice quadratic. I've got my equation in. I've completed the table of values. We've done the equation. Find the price of jeans that generates the maximum revenue. Well, once again, if you think about your graph, right, this is my X. So my price is here, my revenue's here. They're both in dollars. Our parabola looks like this. So it's asking, find the price of jeans that generates the maximum revenue, right? So here, my vertex is going to give me a price and a revenue, right? This will be the highest revenue, whatever price is associated with this revenue. So basically, if I find the vertex, I find the maximum revenue and the price that will give me that revenue. All right, so I go into my second trace menu and I'm going to pick max. I'm just going to move a little to the left, enter, to the right, enter. So I get $50 and a revenue of 62,500, right? So that's my vertex. So the price of $50 will give a maximum revenue of 62,500. Okay, and I just used my finding the maximum. Determine the maximum revenue. Well, it was 62,500. So I answered part C and D actually in part C. So that's it. It looked a little daunting at the beginning, but it really wasn't that difficult, right? If you just pay attention to the words and what they ask you to do. All right, I thought maybe I could go over just a couple of questions. I was hoping that you had started lesson 2 yesterday, perhaps. So I thought maybe I would just go over a couple of questions of lesson 2. And then when we get back next week, when I get back to regular classes, because tomorrow's a work period, we'll talk about systems of equations. But let's take a look. So I'd like you to work on this for the weekend. So maybe if I just do, maybe if I do 1, 2, and 3, and then that leaves me with 4, 5, and 6 for next week to review. So assignment 2, the graph at the right shows the height of a football over time. So football over, this is time, this is the height. How many seconds did it take for the football to reach its maximum height? Well, let's see. Just look for the maximum value, which is right here. The number of seconds would be here then, right? So let's see. 2, 4, 6, 8, 10, 2, 4, 6, 8. So 1.8 seconds, right? In 1.8 seconds. Oops, I answered in the wrong place again. Yikes. What's wrong with me? Sorry. What is the maximum height? So the maximum height is 16, 17, 18, 16, right? The maximum height is 16 meters. How many seconds did it take? 1.8 seconds. For how long was the football in the air? Okay, it was kicked. It goes up in the air, comes down again. So it's here. 1, 2, 3, 4, 2, 4, 6, 8, 10. So that would be 3.6 seconds. And that makes sense, right? The halfway point is 1.8. So 1.8 and 1.8 gives me 3.6. A grasshopper takes a jump in a motion that can be modeled by the equation. So here they give us the equation. Y is the height, t is the time. What does the y-intercept represent? Okay, let's just see. If I just think about this and can be modeled by the equation. Well, I'm going to put the equation in. I'm going to clean my calculator out. Okay, I'm going to enter this equation in. Negative 49x squared plus 160x. Let's see what this graph gives me. Okay, some really strange graph. I'm going to use my Zoom 0. Little trick there. Let's see what kind of windows it gave me. It looks like everything is, I'm just going to match my X and my Y. Or my Y min, Y max. Let's see what happens this time. There's barely any, It's very strange, right? I'm going to reduce this. Sometimes that Zoom 03 thing doesn't really even, that's better. Okay, I'm going to reduce everything then. I'm going to say 500, negative 500. Because the part of the graph that I want to see, I just want to really see okay. Sometimes the Zoom 0, like it really throws you off, right? There, okay. So this is the grasshopper. Let's figure out what the y-intercept is. Second trace value 0, 0. Okay, so that means that this little guy did jump from ground level. I just didn't know if he jumped on ground level or if he was sitting on a leaf or something. So this is the height and this is time. So this little guy jumped up and came down. So it says, what does the y-intercept mean? Well, the y-intercept is 0, right? He was at 0 meters. It means it was on the ground at 0 meters height when it jumped, when it started jumping. What is its maximum height? Okay, well, let's see what this maximum height is. Second trace for, I got to figure out what my left bound is. There it is. Figure out what my right bound is. So the maximum height is 130.61 centimeters. 130.61 centimeters. Okay, so that there again, it gives you, when it gives you the maximum value, it gives you the x and the y intercept. The x is the time that it takes to jump to a maximum height of 130.61 centimeters. So it took this grasshopper 1.63 seconds to jump to a height of 130.61 centimeters. How many seconds does it take for the grasshopper to land on the ground? So I'm looking for this x-intercept, right? We started at 0, then he ended up there. So I think I'm going to change my windows a little bit. I'm going to reduce this a lot, right? Oops. I forgot. I need about 200 there, or 150. Maximum height is 130. Okay. So I'm going to put a y2 of 0, then second trace intersect. Okay, so now I'm watching my y. I have to, it's way down in the negative, so I want to bring it up. Oh, there's my y-intercept. Okay, so I'm going to bring it down. There we go. First curve, second curve, guess. So the grasshopper will reach this at 3.27 seconds. So this is 3.27. 3.27 seconds. Remember, this is 0, and this was my vertex again, right? I'm just going to put the coordinates of my vertex in again, just so I have that recorded for my notes. So this was 1. Whoops. This was 1.63 seconds at 130.61 centimeters. Okay, so what is the height of the grasshopper 1 second after it jumps? That's a really easy one. Remember, it's second trace value. X equals 1, and then we figure out how high it was. And it was 111 centimeters. So the grasshopper height was 111 centimeters in 1 second. So that's old stuff that we learned at the very beginning, but it's hard maybe to remember the old stuff because something new seems to come up every day. All right, let's try number 3. And that'll be the last one I do today. So clear your calculator out. And it gives us another equation. These numbers look fairly small. So the function is negative 4.9x squared plus 5.3x plus 1.2. Oops. Let's see if we can see anything in our screen. I see something right over here. Again, a gymnast is jumping his height. Determine the maximum height. All right, so let's see. It seems like if he's jumping, I'm going to try and figure out what this one would be. Whoops, I entered something in wrong. Negative 4.9x squared plus 5.3x plus 1.2. Let's see what the graph looks like now. That's better, right? Okay, I think I'm going to reduce my windows a little bit. It's just too hard to see. I might even reduce my Y max window. because I don't need all that. Let's see what 5 looks like. Looks like I could reduce my X-max window too. I'm just trying to make it look a little more pleasing for me. And I might reduce my Y a little more too. That's better. It just helps me see a bit better. Determine the maximum height on each jump. Okay, well, that's pretty easy. That's just second calc max. So second calc number 4. To figure out where find my cursor first, just using the back 4th arrows. And I'm looking at these bottom numbers to help me figure out where the cursor is. So enter, enter, enter. So the maximum value is 2.63. So Y equals 2.63. His maximum height is 2.63 meters. Okay, so that's it for today's. I'll go over the rest of these examples. I stopped at the first part of this assignment, right? Given the picture, given the 2 equations, and now we're entering the data in from a table. Number 5 is another data as a table. And number 6 is completing the table and then using the appropriate columns, right? You can only use 2 columns to enter data in, and there's 3 here. So you're going to have to read the question carefully and decide which 2 columns of data that you're going to enter into your calculator, okay? So finish this up for tomorrow, and I will talk to you again on Tuesday, because it's a long weekend, so enjoy your long weekend too. Hopefully you can get outside and enjoy some nice spring-ish sunshine. Okay, talk to you later.